When I was in high school, I remember looking at an equation like this. 2 to the x power equals 8. Now just by looking at the equation, I could tell that x equals 3 because 2 times 2 times 2 is 8. But later that year, when the teacher wrote this equation on the board, 2 to the x equals 7, I was stumped. I had no clue how to solve it. And that's where we begin today, with logarithms. I'm going to introduce logarithm notation, the rules, and how to solve these equations using the best strategy that I still use today. This expression is the notation that we use for logarithms. Log is short for logarithm, 10 is the base, and x is the argument. Now there are some restrictions on the base. It must be positive or greater than 0, and the base cannot equal 1. It can be any other number besides that. There's another very special type of logarithm called the natural logarithm, which has base e. So we can write log base e of x is equal to ln, or the natural log of x, where e is Euler's number 2.718 off to infinity. And the reason it gets a special notation is because of how frequently Euler's number shows up in math, science, and finance. Let's solve this equation involving a logarithm. I'll explain how to do it with just these 3 steps. First step, take the base, go to the other side, equals what's left. X is equal to 10 squared, which is 100. It's really that simple. The thing you have to remember is when you take the base, that just becomes a number. When you go to the other side, that becomes your new exponent and then equals what's left, and you just leave that as it is. Let's try solving another equation. If we have the natural log of e, what does that equal? Because in the end, e is just a number, and all these logarithms that we're solving for are numbers. If I have log base 10 of 2, that's just some number. So now let's solve this one. Remember, a natural log is the same as log base e, so we can rewrite this as log base e of e equals x. So now we take the base, which is e, go to the other side, which is x, so that becomes our exponent, equals what's left, which is e. So what number, x, when we take e to that power, will give us e? Well, that's just 1. X equals 1. Let's try this one now. Natural log of 1 equals what? Let's take the base, and this time I'm not going to write the log form. Take the base, which we know is e, because that's implied. Go to the other side, which is x, equals what's left, 1. So e to what power equals 1? That's just 0. Because any number raised to the 0th power is just 1. Just like many other mathematical objects, logarithms have a set of rules that mathematicians need to follow. The first rule is the multiplication rule. Log of a times b is equal to log of a plus log of b. Next is the division rule. Log of a divided by b is equal to log of a minus log of b. And finally, we have an exponent rule, which says that if you have log of a to the b power, then you move the exponent in front of the log and get b times log of a. These are the three main rules of logarithms. Let's use the rules we just discussed to solve this problem. In the first logarithm, we have an exponent. Remember the exponent rule. Log of a to the b power is b times log of a. So applying this equation to this expression, we get 2 times the natural log of e. Now let's look at the next one, which is division. Remember, we have log of a divided by b is log of a minus log of b. We'll apply that same formula here and get the natural log of 1 minus the natural log of e, and that's equal to x. Now earlier in the video, we showed that the natural log of e is equal to 1 and the natural log of 1 is equal to 0. Let's plug in those values now. This is 2 times 1 plus 0 minus 1 equals x. We just have 2 minus 1 is x, so x is equal to 1. Let's try one more example using log rules. In this equation, we want to solve for the variable z. We have the natural log of some argument, which is other variables being multiplied together, so we're going to have to use the multiplication rule, which is log of a times b is the log of a plus the log of b. Well, let's break this down step by step. So we have the natural log of xy times e to the x. We could say natural log of xy plus the natural log of e to the x, just considering that one quantity. Now we can apply the rule a second time, and we get the natural log of x plus the natural log of y plus, and then here we can use the exponent rule where we pull down the exponent in front of the natural logarithm and leave the base of this exponent. We know from earlier in the video that the natural log of e is 1. So now we can write the natural log of x plus the natural log of y plus x. And that's our answer. Let's do one final example. Log of x plus log of y equals z. Let's try and find what the variable z is. Now you might be saying, well, there's no base on these logarithms. Actually, that's not quite true. Mathematicians write a lot when they're solving equations, so for shorthand, if there's no base written, it's implied that that base is a 10. So this is the same as log base 10 of x plus log base 10 of y equals z. And then we can just apply our multiplication rule and say that this is log base 10 of x times y equals z, or in the mathematician's shorthand, log of xy equals z. And that's it. Now let's use logarithms in a finance example. Here we have the equation for continuous compound interest. It's a equals p times the quantity 1 plus r divided by n, all raised to the nt power. Now p is the principal, or your initial investment. R is the annual interest rate, which is measured in a decimal. So if the interest rate is 3%, then the decimal would be 0.03. N is the number of times the interest is compounded per year. So if it's monthly, for example, n equals 12. T is the number of years, and A is the amount. So let's say I set a goal for myself where I want $30,000 in my bank account. P is my initial investment. So let's say I have only $10,000 in my bank account right now. And in my bank, the interest rate is just 1%. And it's compounded monthly, so n equals 12. How many years would it take for me to reach my goal of $30,000 in my bank account with an initial investment of $10,000? Well, I need to solve this equation for t, which is in the exponent, which means we'll have to use logarithms to solve this equation. Our goal is to solve this equation for t. Let's start by isolating the exponent. Divide both sides by p. Now, just like algebra tells us, what you do to one side of an equation, you must do to the other side. So let's take the logarithm of both sides of this equation. Done. Now let's use our logarithm rules on the right-hand side of this equation so we can pull nt out front. Now let's isolate t by dividing by n and the logarithm of 1 plus r divided by n. This is the time that it would take for me in years with a $30,000 goal and an initial $10,000 investment at a 1% interest rate compounded every month. Now I'm going to use my calculator to solve for t. Well, I've done the math in my calculator, and the answer is much bigger than you might think. T is equal to 109.9, or approximately 110 years. You might be better off investing your money elsewhere. Let me go back to the initial problem I had when I was in high school. 2 to the x equals 7. Using the same method we just used for the finance problem, I'll take the logarithm of both sides, pull down the exponent, divide by log of 2, and that is the exponent that you could raise to 2 and then get 7. The best advice I could give you is what I repeat over and over again in my head every time I encounter a logarithm problem. Take the base, go to the other side, equals what's left. If you do that, you'll be sure to get the correct answer. Good luck, and thanks for watching.